Hello, Season of KDE 2025 is a mentorship program from the KDE community similar to Google Summer of Code. It starts December 15th, 2024, and now would be a good moment to actually prepare for this season of KDE 2025. What is the KDE community? Is a open source project which is developing this desktop environment that you see right now with this launcher and this panel which is called KDE Plasma 6 desktop, and also develops a wide range of applications for Linux, Windows, macOS, etc. And it uses the Qt framework as the basic framework for developing software. And the software is mostly written in the C++ programming language and the programming language QML from the Qt framework. Let's see how we get to the KDE Season of KDE 2025 web page. I searched on Google Season of KDE. It took me to the correct place. And then there's also a wiki page. So I've opened both these search results. This is the official web page, and this is the accompanying wiki page. The timeline is you can start providing your proposal to enter the Season of KDE 2025, December 15th. And then in the first week of January, there will be a deadline. And in 15th of January next year, 2025, the accepted projects will be announced, and then you will immediately start working. In total, you have 2.5 months. You will receive a certificate, and you will receive merchandise and swag from the KDE community. Read this webpage and see for yourself the exact details of this mentorship program. This ideas link take you back to the wiki page, and in here we have the work in progress list of ideas for the current season, SOK, Season of KDE 2025. There's 1, 2, and 3 proposals created by mentors. But you, if you want to participate in the Season of KDE 2025 as a developer or as a contributor, not as a mentor, you should start contacting the KDE community and try to propose something else that's not on this list if this list is too short. Maybe your idea will be agreed and you will get some mentors to help you add your idea to this list. And then good luck being selected by 15th of January. So let's see what contributing to SOK 2025 as a developer would mean. if you did not program for the KDE community before. You can contribute to SOK 2025. Maybe there will be more ideas than only for developers, but this is what I do know, which is how to program for KDE. Let's pick a existing idea from here, and let's see how far we can get into explaining how to contribute to one of these two projects. So there's 3 ideas. There's a future probably KDE project, this Mancala engine. This is still under incubation. It's not really a KDE project yet, but might become in the future. Mancala engine. So this is a game engine. And then there's the KDE project KDE Live, which is a video editor. Let's see this idea, which is related to KDE Live. Let's see how we can, first of all, build the KDE source code. So KDE Live, as you can see, is a Git project hosted on invent.kde.org, which is the GitLab instance of the KDE community. As a minimum minimorum, we should be able to build the application. Let's see the programming languages that are used by this application. C++ 93%, QML. This would be, I don't know, build infrastructure, this small percents for these 3 programming languages. So most of it's C++. Most KDE projects do use C++. And development will take place in a Linux operating system. So you would require to have a hardware device, would be a laptop or a desktop computer that I recommend to be AMD 64, so x86 64-bit Intel processor, not a Apple Silicon processor. And if possible, you should run the Linux operating system on your hardware computers. Or if, for instance, you're using the Windows operating system, then you can create a Linux operating system virtual machine. You could use, for instance, the Windows virtualization software VirtualBox to create such a Linux virtual machine. Let's see how we build KDE Live. For this, we need to follow the procedure on how to start programming for KDE. So the official KDE website, you can find it in here on Wikipedia. It says kde.org. You go to get involved, and then you scroll down until you get to development. In here, it says that most KDE software uses C++ and the Qt framework. And being C++, this means long build times, means elevated requirements for random access memory size, for hard disk space when you build software. And the operating system that we're using for development is one of the Linux operating systems. And you should install it on your hardware computer or in a virtual machine. Let's see how to do it in a virtual machine. If possible, do use a hardware computer, not a virtual machine, because that will be faster. Compile times will be faster. Okay, so in a virtual machine, why would you use a virtual machine? Because you're not using one of the Linux operating systems that we recommend. And the recommended ones are Fedora KDE, KDE Neon User Edition, OpenSUSE Tumbleweed, or Arch Linux. So if you have installed one of these on your hardware computer, on your laptop, on your desktop computer, then you're good to go. If not, if you're using another Linux operating system, or if you're using Windows and do not want to change to one of these supported Linux operating systems, your best bet is to use a virtual machine. And this is the wiki page which tells you how to do it, one of the ways to do it. So VirtualBox is recommended in here because it's a software package that's easy to use by people which start using Linux, people which start programming for the KDE community. It's available on most of the Linux operating systems and on Windows. And it's a free package, doesn't cost anything. So you should enable your hardware virtualization technologies in your BIOS UEFI. It's not that easy to find the checkboxes to enable in there because these technologies have various names. After that, you should install VirtualBox for your operating system, and then you should create a very beefy virtual machine. For instance, my development virtual machines have 14 CPU threads, or vCPUs. I have 10 gigabytes of random access memory and at least 300 gigabytes of NVMe, which is a fast virtual hard disk. You might be able to survive with less resources in this virtual machine, but again, because you're building C++ projects, you're building KDE projects, you're building many KDE projects, the hardware requirements will be intensive. Okay, then you install the operating system. In here it tells you how to install what's called the additions or the guest tools. If you're using the virtualization technology, the virtualization software, VMware, that has, after you install the virtual machine, inside the operating system of the virtual machine, you should install VMware tools. If you're using VirtualBox and inside the operating system, inside the virtual machine, you should install VirtualBox Linux additions. I don't actually use both VirtualBox and these additions. Instead of the additions, I connect to the virtual machine using the remote desktop protocol. And instead of VirtualBox, I'm using Virt Manager because my hardware computer is running Linux. I have this application which uses the Linux native QEMU and KVM. Okay, once you have the needed operating system, next up is to install a build framework from the KDE community named KDE-Builder. Click on this button to get to the procedure on how to set up. So you should have a Linux user account which is able to do sudo. So should be a sudoer. Sudo should be installed on your computer. And then you run the command lines. These two or three. You just copy them and run them in a terminal. Here. And then this one. Then you set up your path environment to include tilde/.local/bin. You run this line, and then from there on you should be able to build KDE software. We have video tutorials on how to install KDE Builder on the supported Linux operating systems, and they're presented in here at the start of the procedure on how to install KDE-Builder. It says if you're a visual learner, we also provide useful video tutorials. So we have one for Fedora KDE 41. You should always use the latest version of the supported Linux operating system, because we need a as new as possible version for the Qt framework and other Linux packages which are needed either by Qt framework or by the KDE software. Then there's KDE Neon User Edition and Arch Linux. Once you have your build environment set up, let's actually use this build environment to build the project that we're after, which is this one, KDE and Live. Okay, so let's see how we would do that. I'm on this computer, I don't have the build framework KDE-builder. I have the previous build framework, which is called KDE-src-build, but they work very similar, have the same command line. So it's a command line tool. When I write KDE-src-build, you just pretend that I'm writing KDE-builder. So we want to build KDE and Live. Let's copy the name of the Git repository. It will build 45 KDE Git repositories. So 45 Git repositories, but most of them, the vast majority, will be from the KDE community. Some will not be from the KDE community. We're not building Qt framework. We're taking the Qt framework version 6 from the Linux operating system binary packages. This build infrastructure knows how to install more than 1,000 packages for your Linux operating system, such that you have the correct packages for Qt Framework 6 and other non-KDE dependencies. And after that, KDE src-build or KDE Builder in your case will build KDE Git repositories. So we want a clean separation between the KDE source code and anything else. Anything else is installed from so anything else in the sense of packages which don't use Qt 6 plus Qt 6. So the Linux operating system packages that do not use Qt 6 and Qt 6 should come from your Linux operating system. The rest of the packages, the KDE Git repositories plus some Git repositories that use Qt 6 but are not part of the KDE community, should come from this build tool, KDE-builder. So this is a KDE Git repository, extra CMake modules. You can find the Git repository. This is the way I do it, KDE invent, and then the name of the KDE Git repository. So KDE invent space extra minus CMake minus modules. I'm searching this on the internet, and I get as a result the correct Git repository, which is https://invent.kde.org/framework/extra minus CMake minus modules. Okay, let's see where we got. So KDE Git repository, another one. This is a very low level KDE framework. And then there are other KDE Git repositories which don't create applications as their build output. Instead, they're building .so files, which are similar to Windows DLL's dynamic link libraries. So this is such a library, a very core library in the KDE community. So these core libraries are in this group in invent.kde.org frameworks. So invent.kde.org/frameworks. These are the KDE frameworks version 6. And there are 90 of them. Okay, so KDE framework version 6 or KF6, KDE framework version 6, KF6, KF6. This is a non-KDE Git repository. This is another KF6. You can see that it's a KDE framework because the build tool says building, the name of the Git repository, and then it says from frameworks. Okay, so it built 35 modules or Git repositories out of the needed 45, and it exited with an error. So the 35th Git repository that should be built out of 45 has a build error. And the build error is that I have used the wrong keyboard shortcut. So I have selected this text, and instead of right-clicking with my mouse and going copy or pressing Ctrl-Shift-C, I have selected the text and then I have pressed Ctrl-C. Ctrl-C, don't ever press it in a terminal because it will kill your current process. So not Ctrl-C, Ctrl-Shift-C in a terminal. Terminals are special, don't use the keyboard key combination Ctrl and C. So we need to start the command line again, kdsrc-build, KDE and live. If you press the up arrow key, it will go through the history. Press enter. So let's see what it's doing. I have built these KDE Git repositories myself using kdsrc-build before. That's why it's going so fast through the KDE Git repositories. When you're building these KDE Git repositories the first time, so when you issue the command line kd-builder KDE and live for the first time, it will build all of these modules from scratch, and it will take some time, minutes, maybe tens of minutes per each KDE Git repository. So KDE-builder, KDSRC-build has finished. It has built many Git repositories of type KDE frameworks version 6, including the 44th out of 45, which is purpose. And then the last Git repository which was built is KDE and live. And it has failed. Why? Because says unable to configure KDE and live, which means that a Linux package is missing from my operating system. So let's see which one. There's this file full path. You could either, in my case, I can just control click on it, or you can go open with Kate, or you can go right click, copy, and load in Kate. Kate is a text editor. I recommend that you have Kate, this text editor, installed. And when developing for the KDE community, you should be inside of KDE Plasma. The operating systems that we recommend have KDE Plasma available, and for instance, Fedora KDE will come with KDE Plasma 6 when you install the operating system Fedora KDE. KDE Plasma 6 will be installed. If you install this operating system, KDE Plasma 6 will be installed. With Arch Linux, if you're installing it using the command line installer application Arch install, then you should select KDE in there. If you install OpenSUSE Tumbleweed, the installer will ask you what desktop environment you want, and in there you should select the option KDE Plasma 6. This is the line that we're after. So we recommend that you use the KDE Plasma desktop on your Linux operating system. And since we're using KDE Plasma, I recommend that you use console as the terminal where you're running command lines, and that you use Kate as the text editor. Both console, this application comes from the KDE community. It says KDE frameworks. It says help about KDE. And the Kate is also a application which comes from the KDE community, is a graphical user interface text editor. Okay. And then you can click on the open button. It should open the file open dialog, and in here you can just paste. If you have a full path to a file, you can just paste where it says name colon and then press enter. So you can also do this without using the mouse, just your keyboard. So this open is Ctrl O, Ctrl V, and enter. Let's see what it complains about. Kate will actually see that the file has the extension log. In the right hand side, this scroll bar is a mini map of the file, and you can see on the mini map that there's a red line in here. Either way, if you're using Kate and you see red lines in the mini map, or if you're using some other text editor, a good idea is to go to the last line in the log file and then start reading from the back towards the start of so from the end of the file towards the start of the file. So in here it complains that it requires a library from my Linux operating system named MLT, and it should be version 7.28, and it says that I have the library MLT installed, but the version that I have installed is 7.24, which is with 0.2 lower than what's needed. So the version that I have installed is lower than the minimum required version 7.28. Let's see if that's true. So I'm on the operating system Ubuntu 24.10. This is not a recommended Linux operating system. Why? Because it doesn't have a new enough Qt version, doesn't have a new enough MLT version, etc. So you should use, again, one of the recommended Linux operating systems. But let's try to see if I can manage to build this software package or not. KDE and live. Okay, so the package, searching the entire list of packages on my computer. We're filtering just for what? MLT. And says that I have MLT++, which is probably the thing that's looking for, MLT++ -7, this thing, and the dev package in here, this guy. And the package version that I have installed is indeed 7.24, and I need 7.28. Okay, what can I do in this case? Let's, I don't know, install updates. let's see the package that's available in the repositories for my Linux operating system. Let's update. Update just downloads the list of packages that are available in the package repositories for my Linux operating system. So it downloads the list of packages that I could install. Okay, apt search mlt. Not too much. Let's grep for dev. Okay, so indeed, there's nothing newer than libmlt++-dev 7.24. I'm going to try to do something that you should totally not do, which is I'm going to try to lower this 7.28 to 7.24 and see if it builds. If not, we're going to try with another season of KDE idea. Where are the ideas? So the Mancala engine. So don't do this at home. So KDE src-build or KDE builder will use these directories ~kd/src for the git clones, ~kd/usr for the directory where it installs build files, build artifacts, and build directory, an intermediate directory where software is built, code is generated, etc. So we want to go to the git clone of kden live and edit with Visual Studio Code and search for this thing 7.28.0. Interesting. So it doesn't specify anywhere 7.28. Okay, let's search for MLT. Lowercase. Like this. PC MLT version string. What is that? Package config. Let me try something, and if it doesn't work, we'll do something else. The CMake framework is used by the KDE community in order to build the software. So C++ modules consist of files with extension CPP, extension .h. The QML programming language will have the files with extension QML, and all of these files, PNG files, SVG files, etc., .md markdown files, will need to be taken, and build artifacts need to be generated out of these. So .so files, executables, the correct code generation steps should need to be run in the correct order. The correct dependencies need to already exist on the system before starting to build. The correct compiler needs to be selected between G++ and CLang++, etc. So all of these project capabilities come from CMake. So we're not using Windows only and Visual Studio VCX Proj only. We're not using macOS Xcode only. We're using something else, which is this CMake. CMake then can be used to generate Visual Studio projects, VCX Proj, can be used to generate GNU CMake files, can be used to generate Ninja build files, etc. So we're at this file, findmlt.cmake, which is a CMake file which locates this library mlt ++-7 in here. And it says that it requires version 7.20.0 minimum. I've searched for this thing, 7.20.8, could not find it, searched for 7.28, and I only found the string 28, which is defined in here. So the version 7.28.0 is actually broken into 3 different integers. And then outside of the build infrastructure, in CPP files, I don't see it being used anywhere, which would actually fail the CMake configure step. So the only place where I probably need to edit is in here. So we should make this 24. Okay. And now if we try to build again, what it will do is, this is a Git repository. We can see that it is. Git remote -v lists the origin remote. We can see that there's a .git directory. There's a git log. There's a git status. And we're going to use the graphical user interface tools from the KDE from the Git project, which are called Git GUI and Git K, to see what's happening in here. There's one origin remote. The Git master branch, the local one, points to the remote origin master branch, to the same Git commit. Who did this? Who Git cloned KDE and live Git repository? Who juggled with the master local branch? This build framework, KDE src-build or KDE builder. And when we're going to run again KDE src-build, KDE and live, it will actually make sure that the master branch points to the same Git commit as the remote origin master branch. And it will, I know, remove the local changes or stash them. Either way, the local changes will disappear. These are the local changes, just one file edited, the top level cmake list.txt file. I have replaced the 28 with a 24. So my options in here are either I do a git commit of this thing in order to not lose my changes, or I use the command line parameter for KDE src-build named no -src. And then, since all of the 44 Git repositories have built correctly, we can also say no include dependencies. Okay, so the name of the module, KDE and live, and then --no src, which means don't do git operations at all. Yeah, I know that the git clone is dirty, the git working directory has a changed file, but I don't care about this, leave it as I have put it. And then no include dependencies means don't build 45 git repositories, build just one, the final one, which is KDE and live. And now it has gone past the configure step, the CMake configure step, which means that our change has tricked the build machineries, and the Ninja build files have been generated. Let's see where. So again, this is a git clone, that's it. inside tilde KD slash KD slash src slash KDN live directory. And in the tilde slash KD slash build slash KDN live directory, we have the build directory. So in here, cmake configure step will create all sorts of directories and files, including the Ninja build files, which is which one? This one, build.ninja. 3 megabytes, a huge file. Let's see how it looks like. So there are hundreds, maybe thousands of build targets, Ninja build targets, and there's the dependency between those targets. So in here it defines the target, I know, this guy, and says that depends on, I'm not sure. But both GNU Make and Ninja are similar in the sense that they, in a plain text file, define a target, so what to do for a certain target, and then it says, before actually doing this target, make sure that you do all of the target dependencies of this target. Okay, let's see where we're at. So 65% compiling. There's a large number of CPP files, C++ translation units. We don't see in here the names of the translation units. For that, we need to add to KDE-src-build KDN live another command line parameter, which is --debug. So --debug increases the verbosity level of this build tool. Right now, it's not that verbose. It only writes 6 lines per Git repository to standard output, to the console, to the terminal. I have a desktop computer which is well cooled, so the CPU central processing unit will not decrease its frequency due to overheating issues. And I have 16 CPU threads, and it still took 2 minutes to build the all of the C++ source code files for KDN Live only. Okay, so it has said that it could build. Again, we're not sure if the build is perfect because we've just entered into the source code of KDN Live and decreased this dependency version from 7.28 to 7.24. So I would expect that some parts of the application will not work correctly. If they do work correctly, it would be, I don't know, maybe by accident. After we've built the application, so this is a graphical user interface application, let's see what it did. So it created a ton of files in here in tilde/kd/build/kd and live directory. There's a bin subdirectory in here. And this is the application that we're after, KDN Live with no extension. It's 202 megabytes because I'm building this C++ source code using CMail build configuration debug, which means it will not strip the debug symbols. So the executable files, all of these are command line executable files, are extremely large because they contain, in this case, there's, I don't know, the executable itself is like 5 megabytes, but then the debug symbols, the symbols that are needed for the debugger to be able to step inside the running executable, I'm going to guess, are 209 megabytes. So the very vast majority of the size taken by this file on the hard disk is the actual debug symbols. Okay, so this executable, maybe it runs if I just double click on it. Okay, I would expect it not to run because the KDE software, after you build it, you should install it. So you should assemble all of the build artifacts from all of the Git repositories from the KDE community inside of the same directory, such that various dependencies, various shared libraries can find each other, and the executable can find the shared libraries, etc. After the executable is built, which is happening here, this executable, so this file is actually copied from here to a single directory where all of the other Git repositories build artifacts have been copied. So they're centralized, the build artifacts from many Git repositories are centralized into the tilde/kd/usr directory. In the case of executables, they live in bin, but .h files live in tilde/kd/usr/include, and .so files live in tilde/kd/usr/lib directory. So in here, in tilde/kd/usr/bin should be a file named KDE-live. Let's sort ascending by name and start writing KDE-live. This guy. Okay, double click on it. Do you want to reset the configuration files? Yes. And it says that it could not find melt, which is part of MLT. So I'm going to guess that I don't have MLT installed. Let's see that. So that would be, let's search for MLT. Says that I have libmlt, which is the .so files from MLT, but I need the MLT executable, so files inside /usr/bin from the MLT free and open source community. So for that, I would become super user, and we want to search for MLT. How can we find the packages? If I would have created the Debian packages, I would put MLT in the name of the packages. Okay, let's, what it did say. I'm going to run KDE-live again and look at the text. So it says melt. Let's install apt file. Let's update apt file. Let's search using apt file. It found smelter. Okay, so there's a ton of results, but somewhere in here should be melt. Can we search for /melt? So we could search for /melt. What about /bin/melt? Yes, so the package is named melt. Apt install melt. So I would say that this is an issue, a bug in the software KDE Live, because at the build time it complains if it cannot find the libraries which are required at build time, but then the CMake files do not complain that you don't have the executables which will be needed at runtime. Unfortunately, when you build software, sometimes there's this separation between the dependencies that are needed when you build the software and the dependencies that you need when you run the software. In my opinion, building should fail if you don't have both the build requirements and the run requirements. But this is a controversial opinion. Probably KDE Live has decided not to search for the runtime dependencies at build time, which is a problem. They should at least warn. I don't know, maybe the CMake files do warn, but we didn't see the output from the CMake configure step. Okay, so we'll need to do this, install the binary package for melt. Cancel, okay. But just double clicking inside tilde/kd/usr/bin on random executables is the wrong way to do it. The correct way to do it is to use this build framework, KDSRC or -build or KD builder, because it has the command line parameter --run. And what this --run does is, first of all, it sets some environment variables, and then it runs this file, so tilde/kd/usr/bin/kdnlive. And the environment variables are set from this file, tilde/kd/build/kdnlive prefix.sh. So it doesn't matter if you're running this command line, kdsrc-build or kd-builder -run kdnlive, or since I'm using the bash command line shell, I could do source and then this file. And then the environment variable path has been modified such that this directory tilde/kd/usr/bin, where kdnlive executable exists, is in the path environment. Let's prove that. So here it is. It's actually at the beginning of the path environment variable tilde/kd/usr/bin, which means that we don't need to run with the full path the executable. We could do, but we can just specify the file name, not the full path. Let's see what it says. Let's reset the configuration files. I don't have anything to lose. The splash screen is shown twice. Let's see what it's saying. So it's using MLT 7.24, yes. Missing application media info and missing some packages. Again, the build time, at build time, it should strongly encourage you to install the runtime dependencies. So let's see that. Media info, what is it? What does it say? Missing application media info. We could search it like this. So it's this package. Let's actually install it. What else? Prior plugins. KDE Live title. Glaxnimate. How do we find those? Apt search Glaxnimate. Glaxnimate. No, Glaxnimate, isn't it a KDE application? What about this Freyer thing? Freyer plugins is what we required, with an O replaced with a 0. And in order to compile C++ source code, we might need the dev package. But since it's a runtime dependency, I'm not sure the C++ headers are actually required. But I'm going to install both this dev package and this dev package. So apt install. I have selected this text, and now I can middle click paste, which I do by clicking on the wheel button on my mouse. Let's see if it proposes also this package. Nope. So I'll install it myself. Okay, for Glaxnimate, I'm not sure, maybe I should build it using KDE-src-build. Let's find out. So Glaxnimate is indeed a project from the KDE community. Let's actually build that. Okay, so this time it will build git clone and build 21 git repositories. If a git repository is already git cloned, it will not git clone it. If one git repository has changes, it will revert those changes. And now it says that it could not build Glaxnimate because probably has missing dependencies. Again, it failed at the step unable to configure, so at the CMake configure step. So it says it could not find Python 3. What does it want to say? It probably requires a dev package for Python 3. I'm going to guess one of these. Found version 3.12.7. Let's see what version of Python do we have installed. .12 and the minimum one for GDBM 3.13. Okay, so probably what we want is this guy, Python 3.12 minus dev. I'm not afraid to install binary packages from my Linux operating system. I can always just uninstall those. I have plenty of space on my hard disk, installing one binary package will not conflict with any other binary packages, so I don't risk anything. The stability of my Linux operating system will not be affected by me just installing dev packages, and especially just installing dev Linux packages, which contains .h files. And dev packages are usually extremely small. Let's try to build again. And now it says the same error. Again, an error with a CMake configure step. And says that it could not find KF5, so Glaxnimate is still using Qt5, not Qt6. And I want to not build any of the modules which use Qt5. Probably can be configured in here. This thing, build with Qt6. Something's wrong in here. I should edit my configuration file and tell for KDE-build and tell it to build Glaxnimate for Qt6, not Qt5. This adventure continues. I needed to edit the configuration file t.config/kdsrc-build-rc to say that the CMake configure command line for Glaxnimate that KDE-build guesses is not perfect, and it should actually also contain this part, the CMake variable, or define what's this thing, -d, named build underscore with underscore Qt6 should be boolean true, because then that thing is used to switch from using Qt5 to using Qt6 when it's building Glaxnimate. Next up, another error, CMake configure step. It says that there's a thing named potrace, which is searched for using find package, so probably using CMake or the package config. So let's search for potrace. Going to search with apt file. Where is it? This thing. I'm searching case insensitive with the -i. This parameter says -i. Apt file search. We'll search for the given string into the files which are available in all of the packages which are available in all of the repositories which are enabled right now in the package manager in my Linux operating system. So potrace, I'm going to guess that it's about the library, not the executable, or maybe both. The library is the one with PC in the file. There's no such thing. So I'm going to guess this guy. Okay. And now, in order to speed things up, I'm not going to build the rest of the dependencies of Glaxnimate. I'm going to build just Glaxnimate. So that's --, no include pen done sees. And the CMake configure step has finished successfully. When it's saying running CMake targeting, so this thing did not show any errors, and it advanced to the next step, which is compiling. So compiling means invoking the Ninja executable, which will read the ninja.build file. Okay, so it's going to take a while. We're going to pause a second. Glucksnimate finished building. I have a hunch that KDE Live will not actually use this thing, but still, we tried. So it has found audio video encoding decoding codecs libraries. I do not want any hardware acceleration. I don't care about it. What should we do now? Can we close this thing? We've installed possible dependencies of KDE Live, and now I want KDE Live to start again and find those dependencies. Let's see how it works. Do you want to reset? Yes. Says that it has deleted the file tilde/.config/kdenlive.rc. It continues to not find Glucksnimate and KDE Live, which are MLT modules. So that means that in your Linux operating system package manager should be packages for MLT executables, for the MLT C++ library, for the development headers, but also these additional modules for MLT. I don't have them. I searched using apt search apt file. I couldn't find these. Okay, let's go OK. And the graphical user interface application has started correctly. It's a video editor. You might have used a video editor previously. I have never used a video editor. I don't know how to do and what to do. It probably has audio tracks, video tracks. You can probably cut and paste. You can probably piece parts of different video files together. You can probably do transitions. You can probably do overlays, show translucent parts of one video on top of the other. Probably you have projects. Probably you can save projects. Probably you can render the final video with audio. And probably a library of I know, video effects and subtitles and who knows what else is inside a video editor. As far as I know, this is the best open source video editor that's used on Linux operating systems. The second would be Shotcut. And then there are non-open source packages for a video graphical user interface video editor. Okay, so the application has started. We can see that it's from the KDE community. We can see the help. We can see that it has started even if we have lowered the dependency of MLT version from 7.28 to 7.24. And this is a standard KDE style toolbar, not a toolbar, a main menu. I would expect these tabs and tool windows to be resizable, reorderable, that you could snap them out and put them in some other place, so similar to what you would do, I know, in an integrated development environment when you write C++ source code. Okay, with the application compiled correctly, we have installed it correctly, we have run it correctly. Next up, what I would do is I would load all the entire application inside a text editor, so inside an integrated development environment, something similar to Apple Xcode or Microsoft Visual Studio, which provides code navigation, debugger, runner, editor for various file types, syntax highlighting, auto-completion, etc., etc., etc. So for that, I'm using the integrated development environment Qt Creator. I have a screen recording on how you can use it. So in short words, there's my wiki page. At the end, I have instructions on how to install and use Qt Creator, the integrated development environment. That's gratis and comes from the Qt framework. I have screen recordings on how to do these. So you should go to the Qt website, which is qt.io. Follow the procedure in here to download this executable, then you will run it. This is called the Qt Online Installer. In the side of the Qt Online Installer, you should select a list of packages to install. After the application is installed, it should be available in the KDE Plasma 6 Start menu as Qt Creator. Start the application, and I have this configured in kdsrc-build rc. So in the configuration file of kdsrc-build, it says that I still have it open. Yes, I do. So in here it says on line 28, it says that the build type should be debug, not rel with debinfo. Rel with debinfo is the default. Debug generates larger files. I want larger files because I want to be able to debug the built applications. In our case, the application is not KCalc. This is just an example. It's KDE Live. So it says that the procedure is that we should build the software, which we did, kdsrc-build KDE Live. And then we should start Qt Creator. I did. And then from the Qt Creator main menu, this is the main menu, we go File, Open File or Project, and then tilde/kd/build, the name of the KDE Git repository, and cmake cache. So we could do it like this. The KDE Git repository is not KCalc, but KDE Live. And then click on the button Configure Project, which is this one. And next, we want to make sure that the executable will run correctly. For that, we need to do this procedure. Let's open a new terminal. Ctrl-Shift-V. There's this file, not for KCalc, but KDE Live. It's the same file for all of the KDE Git repositories. Okay, so this file is identical to this file. It only modifies environment variables in the current bash, after which we can just run the application KDE Live. All of the environment variables are configured correctly, including the path environment variable, such that we can start KDE Live without specifying a full path to ~KDE/usr/bin/KDE Live. Okay, let's run this thing. Okay, and we should copy this part after the last echo. So starting from here and write it to this file. So let's open a Kate, new, Control V, and save it with this name. There's the save button, or we could go with the shortcut of the save button, which is Control S. What did I just do? Control S, Control V, Enter. Overwrite. Okay, and now we need the contents of this file that we have inside of Kate, this thing. I have copied it, so Control A to select all and then Control C to copy. And we need to put this thing into Qt Creator. So let's see where. Qt Creator left sidebar is this rectangle. Projects button has a tooltip. Let's see what tooltip does it have. Switch to projects mode, Control 5. It does. The bold text build and run, this guy. The button run, this one. And then the run settings page, which is this rectangle. We should make sure that run configuration says kcalc. So this thing, run configuration colon, should say KDE Live. Done. The other things are executables, command line executables, but which are tests. We only, for now, care about the executable which is not a test, which is the actual graphical user interface application, which is KDE Live. So this is this part. In the environment group box, which is this guy. So in here, there's a button details. Click on it to expand. And then to the right of the button append path, this is the button append path. To the right of it, there's a multi-line edit box, this guy. And we paste, right-click, paste. And we're at this place. Show in application output when running. This is this checkbox. Show in application output when running. I've checked the checkbox. This thing. And now we can start the application. Let's just start it, this button. Let's see what it does. It cannot run the application without first building the application. Makes sense. We did build the application, but using KDE src-build, which is a totally different thing than Qt Creator. Qt Creator did never build KDE Live before. So now first it's going to build KDE Live, and then it's going to run it. Run the executable KDE Live, which is the actual main graphical user interface application. 467 C++, CPP files, so C++ translation units. And some of these are code generation steps and linker invocations. When starting to program for the KDE community, and when participating to season of KDE, you should keep in touch with the fellow KDE community members. So you do that by creating a metrics account. And then joining at least the following matrix rooms. KDE new contributors. This will help you create the online accounts that you need in order to contribute to the KDE community. They will help you install KDE Builder, the build framework. Then you want to join the metrics room for the season of KDE. Which would be this one, KDE minus mentorship. And then depending on the project, KDE project that you're going to work for, so if you're working for Mancala Engine or for KDE Live, there might be ways to talk directly to the developers working on these projects. KDE Live probably has a matrix room. I'm not sure exactly how to keep in touch with the developers of the Mancala engine. The metrics room for KDE Live is probably this one, kdnlive:/kde.org. So do keep in touch. If you cannot overcome an obstacle, don't invest more than 1 hour to try to fix your issue. Immediately come and ask. So try to fix your issue in a time-boxed manner for an hour. Search on the internet, try something. But then after that, you should ask questions in these KDE matrix rooms, and we will help you progress. The end goal is to get you started contributing to the KDE community, getting you to create your first Git commits, your first GitLab merge requests towards the KDE community, get you have a proposal accepted in season of KDE 2025. There you will have mentors which will help you. So for instance, for this project, KDE Live create animated icon previews for transitions, you would have Jean-Baptiste Mardel, JB. At least this mentor, but probably more. And then you will have the entire community of people which contribute to KDE Live. So don't sit on problems, ask questions. Let's see what's happening in here. So Qt Creator managed to build the software, all 467 C++ translation units, linkers, and other tasks. And then it has started the application. Let's see if the environment variables are correct. So that would be application output. And at the start of the application output, where is it? In here. So it says that 3 minutes ago, it has written all of the environment variables in here, in this tab, in application output KDE Live. And then it has actually started the application KDE Live. The application that runs right now is not from this best place, which is tilde/kd/usr/bin, but instead it's from the build directory. So this thing is running. This thing. How do we know which process is running? We could, for instance, list the running processes. So that's PS, AUX, and then we're going to filter by KDE and live. And says the executable that's running is what I expected, tilde/KDE/build/KDE/live/build/KDE/live. So this thing. But with the correct environment variables set, it will also run correctly from this directory. Okay, so we know how to build using the environment variable Qt Creator. We know how to run. Next up, we want to debug. So that would be from the Qt Creator main menu, debug, and then start and break on main F10. Which is hopefully documented on my wiki page. In here, start and break on main F10. If you've used another integrated development environment before, like Microsoft Visual Studio, the integrated development environments from JetBrains, such as C-Line or IntelliJ IDEA, you kind of know how to intuitively use this thing. So you have the current place where the application is paused inside of the debugger. You have values of identifiers which are visible in this space. So at line 168, there's an argc, there's an argv. Argc is integer 1. Argv is array of char, which is array of strings, UTF-8 style, and has just one item, position 0, which is the full path to the executable that's currently running, the executable of the process. Okay, then there are probably some global variables and other local variables. Let's see this result thing. Okay, the int main is the entry point C++ function of the executable. Might return an integer or not. In this case, it returns. Integer 0 means success, the executable has run successfully. Anything else is an error. So exit success is probably defined as 0. Let's prove that. So I control clicked on the symbol exit success, went to the correct file, /usl/include/stdlib, so the standard library.h. And in here it says that the macro exit success has value 0. The macro is replaced with a literal 0. Okay, so now if we hover on top of result, it will say it's a local variable, it's available in the scope, type integer, and the value, current value 0. You might also be able to edit some of the values. So while the debugger is paused, you can change some values of some identifiers, depending on type, etc. Okay, and then from here on, you use debugging shortcuts, which are these buttons: step into, step over, step out. You can see the shortcuts in here, Visual Studio like. Step over F10, step into F11, step out, Shift F11. If you don't want to go line by line, you can go continue F5, which will go to the next breakpoint. But there are no other breakpoints defined. 0 breakpoints are defined. We can see that in this tool window, the tool window breakpoints. There's currently one thread running, the main thread of the process. And inside the thread, the call stack contains just one function, the main function. Okay, so F11 to step into. F11 to step into. We cannot step into C++ source code CPP files from the Qt framework because we don't have such a thing. We can step into the .h files from the Qt framework. This is probably from the Qt framework. If you control click, it will go to what's available, which is the .h file, which is available. In my case, I've installed Qt framework not from the Linux operating system, but using the Qt Online installer. And it will go to the .h file where the symbol is defined. You probably have the symbols defined for everything that you can step with the debugger over, but you will not have CPP files for all of the symbols. You can see the function signature, or if it's a function or what it is. It says struct, not a class struct, but a struct. And static, what is that? Visibility default, G++ extension. Global seed. So I'm going to guess that this is a static method if such a thing can be put on a C++ struct, which is not a class struct class. Okay, where are we? So we're still in the function main inside main.cpp, and we're advancing F10, F11. So this is somewhere deep inside of a .h file because the Qt framework is using the C++ programming language, so it's heavily using templates, and templates are C++ templates are interpreted at compile time, and a ton of source code is actually stored inside templates and therefore inside .h files. Okay, this method is for an object with Q, so it's from the Qt framework. We don't have the CPP file for it, or for this one, or for this one. But for symbols which are on, in this case, the object k icon theme starts with a K, not with a Q. So Q would be, this thing would be from the Qt framework, whereas these things with K are from KDE Git repositories. And for the KDE Git repositories, we have all of the CPP files because we have built everything from source code using Git clones, using the build framework KDE-builder or KDE-src-build. So in here, if we go step into, we will actually see the CPP file where the body of icon theme is defined. So control click goes to the .h files, where the .h file has been installed in tilde/kd/usr/include. We can see this definition of the symbol. So it's a method static one, doesn't return anything. This is the docstring, which uses the doxygen syntax. And if we go into that step into, so debug step into, now we're inside kicontheme.cpp, so inside the CPP file. CPP files do not exist in tilde/kd/usr/include. Instead, these exist where KDE-builder has git cloned the Git repository that contains this file. The Git repository is tilde/kd/src/kiconthemes. The file is src.ki.theme.cpp. Okay, so in here, probably the Qt Creator thinks that this part is excluded from build, because if not, use breeze icons. But the debugger knows better. So the debugger is GDB, the debugger from the GNU project, and the debugger knows perfectly where to go because we have full debug symbols, because we have configured KDE src-build to use CMake build configuration debug. So GDB knows more than Qt Creator. Qt Creator thinks that all of this part is not run, is excluded using C# bound ifdef, but no, that's not the case, and GDB knows better. Also, GDB knows where each of the CPP file, the full path for each CPP file. Okay, so F10, F10, we can go inside ifs, we can skip. We cannot go inside library paths because this is Qt thing. I have pressed F11, it entered this thing, but we don't have the source code for it, so we can see it in here. In the core stack, it says library paths. Since we don't have the C++ source code, we might look at the disassembler CPU view registry, whatever registers, CPU registers, but that's not that useful. So we can go step out. Okay, so we've stepped out of this black hole, and now we're on line 128. F10, F10, etc. You can put breakpoints. You can switch this view to file system, find the file that you're interested in, and put a breakpoint where you need it. You could search Ctrl+Shift+F for a string that's shown at the application output or that's displayed on the graphical user interface. Find the location and then put a breakpoint near that place. Okay, we'll let the application just run freely. So that's debug, and then continue F5. Splash screen. We can see the SO files that are being loaded one by one by the application that we're running, which is KDE Live. Hundreds of .so files. And now it has stopped to this random place where we put this random breakpoint. So line 99, file filter.cpp. Okay, we can inspect what's inside item. It's a file filter video standard pair. This would be MIME types. Okay, and supported MIME types is a list with 4 items: video MIME types, audio MIME types, image MIME types, and other MIME types. And the type of supported MIME types is file filter DB. And it's a constant. Okay, what is QSL? QSL is a quick Q string literal. The Qt framework, you should start to learn the Qt framework, you should start to improve your C++ knowledge, and then maybe also Qt Quick QML. There are, I don't know, 10 basic C++ Qt string types. So inside of the Qt framework, one of these is this one, Q string literal. There's the views and the let in ones and the prefixes to string literal to literals. So in this case, I'm not even sure if it's okay what's happening here. This is actually a constructor, and you would want to use a C++ literal string prefix in here probably. Okay, this is a more complicated case. There's a ton of threads. Most of the threads are, in this case, related to the graphics. So GPU drivers, for instance, LLVM pipes, these ones. There are other threads which are from a thread pooling, probably library. So a ton of threads that are not doing anything, are just waiting for work to be placed in them. And the very important main thread is probably this one, thread ID 1, the thread where the Qt graphical user interface main loop is running. Or I guess that's the way it is. In many operating systems and in many graphical user interface frameworks, there's one important thread, a main thread, which is probably the first thread that gets created, which actually hosts the main loop of the application, where messages get passed, sent, received, posted, etc. Messages being the mouse has moved, the user has clicked on this button, we should resize the application, we should close the application, Alt F4 has been pressed, Control W has been pressed, etc. Okay, this is the thread 1. So thread 2 has a totally different call stack. Most of the threads are just waiting, not in order for a thread not to consume CPU cycles, it needs to use some synchronization primitive, like I don't know, a mutex or something. Otherwise, if it just loops forever in an infinite while true loop, it needs to make sure that it pauses the thread using something similar to sleep. Otherwise, it would have an infinite loop that's using all of the possible CPU cycles from that CPU thread. Okay, in here we're 7 functions remote from the entry point. So this is the entry point main.cpp function main. In here we're at line 507. We can also see in here. And from this line, the method init GUI is called, which init GUI you can switch between the .h and the cpp file, control click, or right click and switch between function declaration definition shift F2. You can see its definition. It's probably a non-static method. Const qstring reference, const qurl reference, docstrings, part of KDE live Git repository. In here we're at line 193, which calls this init function, which is what? Which is probably also a non-static method. At line 222, which is then calling this build docs, which is also a non-static method. Line 271 in filecore.cpp, which is constructing a media browser. So we're in the seat or in the constructor of media browser. line 148, we can see that we're in the constructor using this combo box. We can switch between open files from this combo box. We have the list of open documents in this tool window. We have a tree view with the source code in this tool window. We can switch to the CMake projects view. Let's go back to where we were, line 148 in mediabrowser.cpp. In here, it's calling one of these, either to kfilter or the builder constructor, or maybe default category. So this is a chain of function calls, so-called fluent API. Okay, so inside the builder constructor on line 212, which is calling this function, which is a static, I don't know, static free function from what I see. Which starts by defining some consts. And then it iterates over the supported types by this supported my times, which can be probably, I don't know, opened by this application or with this, using this application. And decides which MIME type is valid. A ton of F10s. Okay, now we can just press the continue button for this one, main menu, debug, continue. There's a ton of text written in the standard output. I'm not sure what's generating this thing. AVX512 is a Intel CPU instruction set architecture, ISA thing. And the application has started. And that's about all that there is to say about how to start programming for the KDE community, how to start programming for KDE Live, how to use KDE Builder or KDE src-build, how to use Qt Creator, and then how to participate in this year's KDE season of KDE 2005. Thank you.